Welcome back to the bench. Today we've got a repair video. I'm going to attempt to repair this Commodore 64 power supply. This is the wedge-shaped one. I already started working on it and then I decided to make a video. Now, the majority of the Commodore power supplies for the 64 were potted, so they're non-repairable. It's just a complete chunk of resin in there, and this one is kind of like that, but it's a bit different. The transformer section here is completely potted, but the actual section where it converts the AC into DC with the voltage regulator and the rectifier is not potted, so you can actually repair these ones as long as the transformer is still good, in which this case it is. It's still getting an output voltage, but the 5-volt rail is a little bit dicky, so it's probably a bit risky just plugging this straight into a C64 because it might just go pop. So I've already removed the bottom cap on this. It is glued on, so you have to use a bit of brute force and ignorance to get it off. And as you can see, this L shape here corresponds to this, which is isolates the high voltage transformer side to the low voltage output side. Yeah, so that's unfortunately held in there by the potting, so yeah, you literally just have to prise it off, and in this case I managed to crack the case, but yeah, bit of glue and that'll sort that out. So we have a fuse holder here. The best place to attack these is at the cable grommets here, where it's weakest. You can get a screwdriver or something in there just to lever it up, and then you just work your way around. Yeah, it's a little bit chewed up, not too bad. So once it's glued back together, it'll look in a pretty decent condition. Now, I've already taken out the board, and this is very simple. You've got a bridge rectifier here, you've got a smoothing capacitor, and then you've got a little tantalum capacitor here, a little teardrop, resin drop, whatever you want to call it. Pretty sure it's a tantalum. And then here you have your little voltage regulator, only a 5-volt voltage regulator, and it's got a massive aluminium heatsink in here, so obviously that's to keep the thing cool. And yeah, look at the size of this bridge rectifier. For all you rectifier fans out there, it's a Semicron SKB, and then it's got the numbers B40, C3200, and then 2200. So yeah, that's a hell of a beefy rectifier. So yeah, we can see here, this is where the AC goes in. So it goes through the bridge rectifier, and then this great big capacitor is on the input side to the voltage regulator. So that just moves out at 16 volts at 4700 microfarads. And then that's just a little capacitor on the outside, on the output of the regulator, just to make it a bit more stable. So that's all it is. So yeah, all we've got to do is actually replace this entire board. We're not going to use a regulator. You're not going to get this on out there and a new one in there. It's just a complete waste of time. You don't want to go chiseling out, potting, and risk breaking any of the wires down there. So we're just going to throw that to one side. And what we're going to do, I've already started putting some wires on there, is we're going to replace the bridge rectifier with this one here. So I've already soldered on the output wires, and I just need to solder on the input wires. So we'll do that next. And then once that is done, I'm going to put this board in, which is a buck converter. So this is going to take our output from our transformer after the rectifier, and then drop that down to 5 volts. And it's already got the capacitance in there that it needs for smoothing. This is using an LM2596. These boards you can get off eBay for €1 or €2 a piece. They usually sell them in lots of 5 for a few euros. So yeah, they're pretty inexpensive, and these things will run up to about 3 to 4 amps. So yeah, there's no worry about it overheating or getting stressed out. It'll easily run our Commodore 64. So further ado, let's put these other wires onto this bridge rectifier, and then I can start soldering this into place. And what we'll do is we'll just do a bit of load testing before we actually, you know, put it all in there and get it soldered together. Just get the wire as close as possible to the leg of the rectifier. Let's go on the other side. That'll do. It doesn't have to look pretty. We're going to shrink wrap it afterwards, as long as it makes a very good connection. That's better. Give it a few seconds to cool. Okay. And then put on the last wire. Stay still. There we go. Okay, so we've got a bit of heat shrinking. So let's just cut that. Probably about in half should do it. Yeah. These little pieces. There's no possibility of anything shorting out. And yeah, as you can see, if you can see it on the rectifier, it's a bit dark. They are actually, terminals are actually marked. Those little circle dots, they've got the symbols in there for the AC input and the positive and negative output. Okay, let's use a lighter just to heat that up and shrink it down, because I don't have another heat source. That's that done. So here's our AC output from our transformer. What I need to do is just put some heat shrink before I forget on those wires, so that once I've soldered these I can then slip this down and then insulate it, because obviously that's a big piece of metal there. You don't want bare wires touching that. The actual wires from the transformer themselves are actually enamelled, so that's okay. Well, obviously our solder joint won't be any. Up so that we can get a good connection. This one's out of the way. A few seconds to cool. That's good and firm. Okay, let's put our heat shrink down. So that's our bridge rectifier on, so what I want to do is just test that. Now, this is live mains wiring, so you have to be careful. I'm just going to pop this over there just so I don't accidentally brush against them. So yeah, if you're going to attempt this, you do it at your own risk. Obviously, I've worked with mains electricity a lot, so I know what I'm doing. I'm just going to plug this in. Okay, and then I'm just going to get my meter. I just want to check the voltage coming out of that rectifier. Okay, so we're getting 9.3 volts out. It sounds about right. Okay. Okay, there's no capacitance in there, so the input side as far as I can see, so there's not much point of getting any shock off of that, but yeah, I'm still not going to stick a finger in there. That's output. We want input. A few seconds to dry. Power supply is live. So let's measure our open circuit voltage. .48. Okay. Now we should be able to wind that in. .47. Oh, let's try it the other way. .42. Yeah, it's going down now. So I'm only getting near 5 volts, but that's way too low. That's 1 volt. Okay. Rather than trying to adjust it, and change it and then adjust it again. Okay, so we're at 1.257. Okay. Okay, so that's a little over 5 volts. Two sets of these leads, so I'll have to, unless I can use, yeah, I'll plug the meter directly into the load. Okay, yep. So we can see that we've got our 5 volts. Let's put our load on. Okay. So our load's reading 0 at the moment. You can see that bit of light. It's a bit of a strobing effect, but it looks fine to my eyes. So I want to wind that up to about an amp. Oh, it's topping out at an amp. So yeah, it's not going to supply much more than that. And then I should just need to just adjust this. Until we're up to 5 volts. Rectifier is getting slightly warm. Okay, I've pushed our current up to about 1.2 amps. I'll wind that back down. Okay, so yeah, I'll switch off our load. Okay, so our open circuit voltage is about 7.2, which seems a little on the high side. All that's left to do is just connect it to our output. Now if we take a look at our PCB, the green wire was soldered to here, so that's our out, our negative, yeah, and then that's our positive, so just make sure we get them the right way around. Don't want to get them connected the wrong way, otherwise we let the magic smoke out. The wire is a little bit short, but we can just mount that there. We just put a little bit of insulation in there just to make sure that nothing touches that. Mind you, by the time we get some hot snot in there. So yep, that will just fit in there nicely with a little bit of insulation over the metal, and then we'll just put a little bit of hot snot in there to secure it. And then once that's all done and tested and we're happy with it, we can just pop our cover back on. I'll have to cut off a few of these things here, that's not a problem. And then yeah, we can just glue that back on. We can just get rid of these pegs because they're no longer required, because they're what used to hold it together before. Just trim these down so they don't get in the way. You also have to file that down a little bit as well, just to take it down to make sure it doesn't impede the case. And as you can see, once it's there, and we can just glue that back on, and yeah, it'll look as good as new. It'll probably work better than it was when it was new. Okay, so that is how you update one of these old wedge-shaped power supplies so that it runs on a modern buck converter. So, you know, if you like this video, then don't forget to subscribe, and also ring that bell icon if you want to get notified of new videos when they get uploaded. And yeah, so I will sign off, and I will see you in the next video, and hopefully I'm going to do some more testing on this first, bit of soap testing, run it over 24 hours, make sure everything's still okay before I plug it into a real C64. Okay, so from me, it's over and out for now.